Hello and welcome to the GCSE Physics tutorial for topic P7 Magnetism and Electromagnetism. This tutorial will cover magnetic fields, electromagnets, electromagnetic induction and transformers. First of all, magnets. Magnets produce a magnetic field around them, and as you can see from the diagram, a magnetic field always goes from north to south pole. The field is stronger when the lines are closer, which means the magnetic field is stronger at the poles. The magnetic field is an area or region where magnets and magnetic materials like iron, steel, nickel and cobalt experience a force. In terms of magnets, like poles repel each other and opposite poles attract each other. A compass can be placed around a magnet to show the direction of the magnetic field as shown in the diagram. Permanent magnets produce their own magnetic field, and induced magnets are magnetic materials that become magnets when placed in a magnetic field. A current flowing through a wire produces a magnetic field around the wire, as shown in the diagram. If you change the direction of the current, you will change the direction of the magnetic field. Also, if you have a larger current or a closer distance to the wire, that also produces a stronger magnetic field. A solenoid is when the wire is wrapped into a coil. This makes the magnetic field lines produce stronger. If the solenoid is placed around an iron core, it makes the magnetic field even stronger. Magnetic field can be switched on and off when connected to a power supply, so this creates an electromagnet. Electromagnets can be switched on or off and have various uses, which we will discuss. The motor effect. A wire that carries a current is placed between two magnetic poles, as shown in the diagram. This creates a magnetic field that then interacts with the magnetic field between the two poles. The magnet and the wire then exert a force on each other, causing the wire to move. This is the motor effect, and it works if the wire is at 90 degrees to the magnetic field. You can use Fleming's left-hand rule to find out the direction of the force and in which way the wire will move. Loudspeakers. They have electromagnets inside them. A current is passed through a coil and it's an alternating current. And that goes through a coil of wire around a magnet. This is inside another magnet. This current then creates a force in the wire which makes the cone move. And because it's an alternating current, when it's reversed, the cone moves it back. This constant variation of the current makes the cone vibrate, and that gives out a sound wave. Electromagnets are also used in motors. A motor is made up of a coil of wire carrying a current rotating in a magnetic field. There is something called a commutator which keeps the motor turning in the same direction. Fleming's left-hand rule can be used to find the way the coil will turn. What is electromagnetic induction? Well, if you move a magnet in a coil of wire as shown, or a wire in a magnetic field, you can induce a potential difference and create an alternating current. This is how generators work in power stations to produce electricity. If you move the magnet quicker, or you increase the size of the magnet, then you'll make more current. Alternators produce an alternating current. This is shown in the diagram below. As the coil spins, a current is induced which changes direction every half turn. This is because of the slip rings and brushes as shown in the diagram. An alternating current can be seen on the graph. Dynamos work in a similar way, but they have a split ring commutator, and that keeps the current flowing in one direction as shown in the graph. They're used in bicycles, and the magnet turns because the wheel turns when the person cycles. And then this can be used to, for example, create electricity, which will cause a bike light to go on. Microphones work in a reverse way of loudspeakers. This time sound waves hit a diaphragm, a flexible diaphragm that's attached to a coil of wire inside a magnet. That causes a wire to move, and then that creates a current. So the sound wave creates a current. Transformers. You will have heard about transformers before in the previous topic on mains electricity. They change the size of the potential difference of an alternating current, and they're made of two coils of wire, primary and secondary, and an iron core. Step-upward transformers have more turns on the secondary coil and they increase the potential difference. Step-down transformers have more turns on the primary coil and decrease the potential difference. When an alternating potential difference is applied across the primary coil, the iron core magnetizes and demagnetizes quickly. This changing field induces an alternating potential difference in the secondary coil. Transformers are part of the national grid. You need to know the calculation below, which can be used in transformer equations. If you pause the tutorial now and try these two questions. First of all, how would you find the magnetic field of a permanent bar magnet? You can either place the magnet on a piece of paper and sprinkle iron filings on, which will give the shape of the field, or place compasses around the magnet, and the compasses have a little magnet inside them, which will start to move and show the direction of the magnetic field. How would you build an electromagnet? Well, you get some wire and wrap it round an iron nail. You will then connect the wire to a power supply and switch on, so that a current is going through the wire. You can then use that nail to pick up paper clips because it will be magnetised and record how many paper clips are picked up. You can vary the strength by either increasing the potential difference on the power supply or wrapping more coils of wire around the nail, and that will make the electromagnet stronger. In summary, we've looked at magnetic fields, electromagnets, electromagnetic induction and transformers.